my business. I suppose you might even say it's been my whole life. Looking back over 40 years, I don't suppose I'd have been as happy doing anything else. Just about the first thing I can ever remember wanting to buy was something packed in glass. Yes, I had to have that goldfish bowl. My difficulty at this particular time was money. Still is. But just then it was acute. Money, that was the stuff. But how to get some of it quickly? Ask my mother for an advance on next Saturday's... No, that wouldn't work. Ah, wait a minute. Jam jars. You'd get jam jars for nothing. All you needed was the enterprise to knock at the door and ask politely, then take them to the corner shop and collect the pennies. Easy. Or so I thought. It didn't take me long to find out that to be a successful middleman, you must know how to approach your supplier. Apparently my approach left something to be desired. A few rebuffs soon improved it. Success came, and with it, fierce competition. You had to keep a door or two ahead all the time. My rivals had certain advantages. An efficient transport system, a valuable goodwill with the customer, and they were bigger than I was. Still, fortune smiled on me, and I made my first deal in glass. Now I had the money, but did the man still have the bowl? He did. What a moment that was. Even the painful episode that followed explaining to my father exactly how I got the money to buy the bowl never quite dimmed it. Still, it was perhaps this early promise in the glass business that prompted my father to apprentice me to a glass manufacturer. He was a great believer in starting at the bottom. I started at the very bottom, fetching the beer. The hours were long for a youngster. I worked a 55-hour week, then went to night school, learning how to make glass and making money for the first time. 8 shillings a week. No, it went a long way in those days. On Saturday night, you could buy an enormous steak and kidney pie supper, wash it down with a bottle of bright red pop, smoke an illicit packet of Woodbines while you watched pearl white pictures, and still have a halfpenny left out of a shilling if you walked home. Life is very different for youngsters coming into the industry today. They go to school during working hours, their tuition paid for by the company. The first thing they learn is the chemical composition of glass. Sand, limestone, soda ash, and cullet, that's broken glass to help the melting, plus heat at 1,350 degrees centigrade equals glass. It's still a source of wonder to me even now that from such dull, opaque materials you can produce something of such crystal clarity that it's almost like solidified light. Or we can give you color. A very minute quantity of a metallic oxide at the mixing stage produces colors clear and bright as jewels. Many of these colors have become traditional, especially in the bottles supplied to the pharmaceutical and chemical trades. Then again, the colors can be purely decorative, to add glamour, the eye appeal, the sparkling beauty of glass to cosmetic packs. Now we design labels as part of the container, multicolored and so beautifully printed that even the smallest type reproduces legibly. The colors remain brilliant and indestructible because they are fired to become part of the glass. Very often, containers are needed in relatively small quantities, and for this reason, we make them by the semi-automatic process. This process is most economical for short runs and allows more flexibility in use of colors because the glass is made in smaller batches. They make it look easy, but believe me, this is a very highly skilled job, and coordination between the team has to be perfect. But when we go into mass production, the operation becomes a miracle of modern automation. With only 27,000 people in all branches of the industry, we produce well over 4,000 million glass containers every year. glass factory can never sleep. Once the molten glass starts to flow, it has to keep flowing, 24 hours a day in, day out, year in, year out. Control has to be absolutely precise at every point. You can't afford to take chances when you're dealing with hundreds of tons of materials. Some visitors find it all a bit awe-inspiring. The roar of the furnaces and the vast reservoirs of molten glass. Look through the peephole and you see an inferno. A friend of mine once said it must be like working with a volcano breathing down the back of your neck. Well, I suppose it is, but it's a very carefully controlled volcano. These treacly blobs are molten glass, sheared off to precise weights to be molded to shape and size. Mold making is an art in itself. It calls for a careful, painstaking craftsmanship of a very high order indeed. When I first saw one of these machines, I just didn't believe it. And between you and me, I'm not too convinced about it even now. You wouldn't believe anything so complicated could possibly work, but it does. Right through the night and day, one of these machines can turn out up to 140 containers every minute. They must be among the most ingenious machines ever invented. And though they are enormously complicated, what they do is really very simple. Narrow neck containers are made by what we call the blow-and-blow process. In this process, the gob of molten glass drops into the first mold, we call it the parison, like this. The top of the mold is covered by an air duct, and compressed air forces the glass down to form what will become the neck of the bottle. A plate now takes the place of the air duct at the top of the mold, while at the bottom, the plunger that has formed the neck is retracted. An air duct now takes its place at the bottom and blows air through the neck hole. This forces the glass back up to the top of the mold. The mold now opens, leaving the parison shape held by its neck ring. The ring now turns the parison the other way up. A second, finishing mold closes around it, and an air duct moves into position at the top. Compressed air blows the glass out against the walls of the finishing mold to give the bottle its final shape. The molds withdraw, and there is your bottle. For wide neck containers, we use the press and blow method, and the action is very similar. The gob drops into the parison mold in exactly the same way. A plunger comes down to form the neck opening. The plunger withdraws and the mold releases the parison, which is held now only by its neck ring. The finishing mold and the air duct move into position. Compressed air blows the parison out to the shape of the finishing mold. The mold releases, and there you have a jam jar. It looks simple, but everything has to happen with split-second precision. In the time it's taken me to explain, one machine performs this operation over 200 times. Now the container is the right shape, but it's still very hot and soft as putty. This is where the really tricky part of the process starts. If we let the glass cool too quickly, it will be full of undesirable stresses and very brittle. So we anneal it, controlling the rate of cooling in a big tunnel we call a leer. The new container starts life moving through this leer at a sedate, relaxed pace, cooling and hardening as it goes. When it emerges, the modern glass container is tough enough to meet almost anything. What it meets, in fact, is a very tough inspection. If the container has any defect discernible to the human eye, its career as a container finishes right there. You might think somebody would have devised a machine to do this. It isn't because they haven't tried, but no electronic device yet designed is capable of detecting flaws as efficiently as the practiced eyes of an experienced sorter. But checking doesn't depend solely on this. Quality control departments take samples from all molds at regular intervals. These departments employ instruments to look deeper than the human eye possibly can. Take this one, for example. Now, this machine gives us a magnification of the neck of the container. On it, we check the accuracy of a number of things, such as the screw thread against a calibrated screen. And we use a variety of instruments for other checks. Like to split a bottle? We do it all the time, sawing them in half to measure the distribution of glass throughout the container. Another thing we've obviously got to know is just how much pressure a container will stand. Samples taken from the run are tested to destruction to make certain they will stand pressures very much higher than those required by any packer. One of the most intriguing pieces of testing equipment is the polariscope. It enables the operator to see something that is quite invisible. It shows stresses within the glass by translating them in terms of color, so that an expert operator can diagnose where stresses are of an undesirable nature. This particular machine is in the glass industry's new research laboratory at Sheffield. This laboratory serves the whole industry, and because glass is a complex material, manufacturers send samples of glass for spectrophotographic analysis. In this way, we have built up a vast library of photographic records, rather like a fingerprint department, which enables us to identify and deal with troublemakers quickly. And experiments in these furnaces are successful. It is constant research of this kind which has made it possible for us to keep the cost of glass containers stable and at the same time improve our quality. The new laboratory stands alongside Sheffield University, where the world's first department of glass technology was founded in 1917. Youngsters entering the industry today can take up either fundamental research into the secrets that are still hidden in glass, and we find out new things about it almost every day, or they can go into the practical business of glass making and selling. If they choose commerce, then the first thing they must study is design. You can make a glass container in almost any conceivable shape, but to get the economy of high-speed production and have a container of high mechanical and thermal strength, you have to accept some limitations on design. Not many, but some, and they're relatively simple. We make containers by blowing viscous glass. By nature, the molten glass would like to take the easy way out and become a bubble. A complete sphere is just about as strong a form as it's possible to make, because the glass disperses evenly. Unfortunately, a completely spherical container isn't a lot of use for packing anything, except maybe goldfish, and there aren't many goldfish packers around. The next best thing for strength is a container with a circular cross-section. The strength decreases as you depart from this circular cross-section. Taking the circular cross-section as having the strength of 10, an elliptical one has the strength of 5, the square with rounded corners 2.5, and a square with sharp corners has a relative strength of only 1. But even so, its strength would be adequate for almost any purpose. Now, why are square corners weaker? Well, when you blow glass into them, a thin spot like this develops. The way to avoid this is to have an in-swept junction or rounded corner so that the glass disperses evenly. Then again, there are practical considerations, the need to have a low center of gravity and a firm base to stand on. A classic shape like this might look very pleasant, but it would drive everyone crazy because it would topple over too easily. Turn the design upside down, and you have a shape which might keep everyone happy and still look just as pleasant. You know, when glass manufacturers have nightmares, they dream of shapes like this. Mind you, we would try and work it some way, but the golden rule in designing for high-speed production is as few sharp angles as possible. The principles of good design are a basic study for all youngsters coming into the industry today, because a container must do more than just contain the product. To be truly efficient, it must make a real contribution to selling it. And because we realize this, the glass industry has been able to make a material contribution to good container design in recent years. Now we're producing packs that not only contain efficiently, but are a pleasure to look at and more economical than ever. Take the standard jam jar produced by the industry's research committee. To my mind, it has a beauty all its own, something designed to be perfectly fitted for its purpose. If you compare this new jar with those old designs, you'll find that 5 new jars weigh no more than 2 of the old ones, yet the new ones are even stronger. Many of these designs have evolved from close liaison between packers, glass manufacturers, filling machinery makers, and closure manufacturers. Cooperation on product presentation grows closer all the time, but there still remains one unknown factor: the customer's preference. So we now offer the packer a range of testing services that have been specially designed to help take some of the guesswork out of developing new designs. A team of trained interviewers show models of new designs to a consumer panel of 400 households spread across the country. They record the panel's preferences and opinions. When data cards from these interviews are tabulated and analyzed, they give you a pretty clear picture of what the consumers are going to like or dislike, and what modifications it might be necessary to make, so that you know you're on the right lines before you go into production. You can carry this type of test a stage further and test the container and the product in actual use in the home. The consumer panel's experience of using the container at home for, say, a fortnight is recorded and analyzed. Research of this kind very often reveals factors of habit and use which could not be determined in any other way. At the same time, they produce very interesting data on the consumer's attitude to the product itself. These services have brought the packer and glass manufacturer closer together to study our joint problem of developing packs that will help to sell the product. But when we have found out if the customers like the design, we have just about half the answer. Now we need to know, will it display well? Will it stand out against its competitors on the shelves of retail stores? And most important of all, will the customers buy it? To help answer these questions, we offer the packer a further service. We will place packs on the shelves of a representative selection of self-service or other stores and audit the volume of sales. We can then see how it sells compared either with other packs or competitive lines. If he wishes, the packer can test quite anonymously by labeling with any one of several brand names we have registered for the purpose. The industry now carries out a continuous program of research along these lines to produce practical marketing data. We have set up the Container Acceptance Testing Service to handle these market testing operations for packers as a free service, because we believe that nothing but good can derive from making the fullest use of them. We have, after all, an identity of interest here to develop glass containers that will sell more goods. And anything that helps in this endeavor must benefit packer and glass manufacturer equally. Look at that. My, the youngsters of today don't have to get up to the antics that I had to for pocket money. Well, I'm blowed. Maybe I'd do just the same thing myself today. Ah, well, perhaps small boys never change, only things change. At his age, the limit of my aspirations was a goldfish bowl. His spaceship already encircles the universe. But in this changing way of life, of one thing you may be sure. Glass, always changing but serving constantly, will still play a part in bringing everyone the good things in life.